Okay, here we go. Unit analysis. It's a way of looking at equations and seeing if they make sense without even having to look at the numbers. If we pose ourselves in a situation like, I want to find out how far I walked today. Well, I first walked a short distance, and I stop. Then I walk a little bit farther, a little bit more, stop again, then walk a bit farther. Can this equation here be used to calculate how far I went? Well, how far I went can be measured in meters. All these distances are measured in meters. If we look at this, that makes sense. You can add a distance to a distance. However, if I said how far did I go and someone says, oh, I traveled for 60 hours, and then I stop for a while and I travel another 6 miles, then, oh, by the way, I have a certain amount of mass about me. I have 40 kilograms of mass. Does this make any sense? No, we know we can't add these quantities together. We know we cannot take a time, add it to a distance, and then add it to a mass? No, it just doesn't make sense. And things like this, when we look at the units, make much more sense. I know everyone's had someone tell how far away is Chicago, and you're like 40 minutes. It's time. Now, if you've done any type of conversions ever, maybe even stoichiometry, you've seen this type of thing before. If we want to convert 45 kilograms, I don't know, say to centigrams or something, we know the process by which that's happening. And we want to find centigrams, so whatever on the right should be in centigrams. Notice how all of the units, only look at the units, how they all cancel out, and we're left with centigrams. Now, if we tried this a different way, I wouldn't find out centigrams, and over here I found meters, we would know there's something wrong with the equation. This is one for math. Distance equals rate times time. Distance, we know, is measured in meters, in science at least. A rate is just a distance per time, like miles per hour. Here we have meters per second. And then time, once again, is in seconds. If you cancel out the seconds, we're left with meters equals meters. That works in math. Let's take a look at a more difficult equation. This is one that's commonly used in physics in a field called kinematics. It's a kinematic equation. Let's see if dimensional analysis, unit analysis, shows up to this. We should be able to show this equation works. Distance is measured in meters. Rate, it's like before, is in meters per second. Acceleration, it's actually a change in speed, how much your speed is changing. It's meters per second squared, and time is still seconds. So we take all of these units, we plug them in. We don't even care about the numbers. This 1/2 here, it's a number. We don't care about it. We're only considering the units on this. Plug in the meters per second squared and the time squared. Seconds start canceling, seconds squared start canceling, and what are we left with? Meters is meters plus meters. That makes sense. All right. Now, if we were to post something maybe that didn't work, let's take a look at something that didn't work. What can we do? We can, I don't know, I'll just make one up. Distance equals distance times time plus it. I don't know. If I'm just making something up, it's probably gonna be wrong. So let's take rate, the rate times acceleration over time. Let's see if this works. Meters, and I'll just plug in the same stuff, see if it works out. Meters, okay, now I'll start canceling stuff. Or actually, let's start bringing stuff together. Meters over seconds times meters over second squared. You see how it goes. Now I'm just going to do a little bit of math here. We have to divide all that stuff on the bottom also. Oh, this is ugly. Meters squared. Second, fourth, I have no idea what that could possibly mean. I know it's ugly, but I know at the very least it doesn't match up with here's on the left. Meters is not equal to meters times second. So it just makes no sense to me. It also, especially if you add on this other awkward unit to the right, there isn't any balance to it. In math, whatever is on the left side of the equation has to be equal to the right side, and this just doesn't match up. And that's really all unit analysis is. It's looking at the units, making sure everything on the left side and right side match up. If they do, the equation is valid, or potentially valid. But if it doesn't match up, then it's definitely wrong.